So, hello everyone. I have done a post on Facebook recently, and some questions um, were coming out from this post regarding the force system and the movement and the reaction and so on. So I would like to discuss a little bit about this case, which at the beginning I didn't think was so interesting, but it might be nice to have a little and short lecture about this. So when I made this post, my original intent was to show this little trick to have a cantilever working in spite of the fact that you don't have a free bracket. So let's see here, and first let's see this point. Here we have this unit where we have this teeth here, and there is a segment, a wire, which is connecting these three teeth. Now I don't have a tube or a free slot or a bracket in order to engage another wires and to use a cantilever. So what I've done, I've created a big loop here that is also connected with the cantilever. So it goes like this. And as you see, if you make this loop go around the wire of the segment, you can create a two-point contact here. This two-point of contact make a system which is exactly the same as if there was a bracket here. So just imagine that here we have created a bracket and we have engaged a wire inside here. So bending the wire here, we can activate the cantilever. We can make a different shape of the cantilever, which is later to be activated in this direction. And this activation in this direction, so here we'll make a ligature, will create to this unit the force and the moment. That's the only thing I wanted to show. So just this little trick to make a double point of contact and so build up a cantilever. Well, now, before discussing the biomechanics and the force system and make a little bit of real static analysis of this case, let me look at this case with the eyes of an orthodontist and let's try to see which are the problems that I see for this case. Actually, in this case, I had for this lateral here a problem because the lateral was edge-to-edge occlusion, so I would have liked to bring this out. At the same time, the overjet at this level was too much, so I would have liked to bring this in. So you really understand that there is a rotation of the whole group, and this is also consistent with the fact that we need to move the midline in this direction. Then we have another problem here to the lateral, which is again too palatal, so I need it would be nice to bring this out. And the canine here in my treatment plan needed a very limited buccal movement. So this is what I would like to get very roughly. That's not a very precise treatment goal. Definition is just a clinical evaluation just made at the chair. So with this in mind, we start describing the force system that I'm going to apply. Now you see the two units that are represented here with the CR, the red and the blue unit. We will work with these two dental units for a reciprocal movement which is absolutely consistent. Here you see these two arrows that represent the line of action of the forces that are generated by the cantilever. The blue arrow represents the activation and its equivalent of the force system which will be delivered to the CR, to the blue CR. The other one is equivalent to the force system that will be delivered to the red unit. Okay, what you see here are the two force systems equivalent to the single force that you have just seen, and these are applied to the two CRs. And as you see, since the line of action of the force is passing more or less here, the distances are not the same, and therefore we don't have the same moment to force ratio. So this makes me think and estimate that the position of the center of rotation is different on the two sides. So the distance between the center of resistance and the center of rotation is related to the moment to force ratio. So for this reason, you see that I have estimated the position of the center of rotation of the red unit more distant from the CR than what happens in the blue unit. And this means that you will have more rotation for the blue unit and more translation for the red unit. So here you see the movement that we can anticipate thinking to the center of rotation. And here you see the alignment I'm thinking. And finally, this movement was clinically obtained. This is just a simulation I've done on my computer. Unfortunately, I didn't take a picture 1 or 2 months later than the use of the cantilever. So here we have an image that was taken for the same patient 6 months after the application of the cantilever, and we can see we have a nice alignment. However, this is not something that can tell you exactly what has happened, because other things were used after the cantilever. So this is just to show you something, but is not really what is the result of the cantilever use. I'm anyway very happy of having used this case for this discussion and this little lecture, because it is a very simple case, and I think it's very clear how we can, with our procedure, predict the force system and the movement of the teeth. This case is very simple, and I would say that you could have obtained a quite good alignment even if you were using an eye-tie wire or even a segment of an eye-tie wire, but the control you can have in using this approach with segmented arch is definitely better. So thank you for your attention.